So happy to see, well, I see some of you and I don't see some of you, but I see some names that I recognize and some names that I don't recognize. So I'm very excited to have a good group here for thinking about, particularly with high school and middle school, high school, and teachers of that age group. How do we think about getting learning opportunities in front of our students and in front of our teachers that allow them to learn something about what it means to do data science. And so I'm going to go ahead and start sharing my screen, but as Talia had said, this is participatory by design, and there's going to be lots of opportunities for you to actually be playing with data and taking a look at some different things, and also being actively providing feedback and answering some questions along the way. So I hope that you didn't just turn on and you're going to sit in your office and eat breakfast and eat lunch and not participate, because as any good teacher, I might call you out on that. So,
and in fact, we have found in past webinars that if you share your video, if you have a webcam and are willing to share your image, that helps us feel like a seminar more than a traditional webinar. Thank
you. This is definitely not a one-way talk at you for an hour and 50 minutes. So I wouldn't know what to do with that time. Anyway, so let me share my screen and get started. All right, so there is the title. I am located at NC State University, and the work that I'm going to be sharing with you today is partially supported by two different grants, one from the National Science Foundation that I'll tell you a little bit about later, as well as from the William and Flora Hewlett Foundation. So as Talia said, we are, I have organized a Google Doc with lots of different links that we're going to be using throughout the webinar. So it really is quite essential that you go to this URL. And so if you have not already gotten it from the chat window, this is what you can type into your browser and join us in the Google Doc. tinyurl.com DSET-June 19.
It's fun to see everybody popping up there.
Good, 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 good. Don't delete any of my stuff. All right, so we're actually not going to be using any of those links for a few minutes, but it's helpful just for everyone to get there so that when we're ready, we are all at the same location. So let me just tell you a little bit about how I came to start thinking about data science, and this is going to give you like this fast forward version. In the 1990s and the early 2000s, I developed my own software for simulation and data exploration from chance contexts, and did some work with students learning in that environment. I was also an early field tester and user of tools like Fathom and Tinkerplots. That I think I first met Bill Finzer. Bill, I'm thinking it was like 1999, maybe at a NCTM conference, something like that. Then from 2005 to 2014, I was involved in a project here with some colleagues at NC State to create curricula for preparing teachers to teach with lots of different tools, but I was particularly focused on using Fathom and Tinkerplots, and getting that in the hands of teachers that eventually would hopefully get them in the hands of their students in their future classrooms. And then I was really involved in examining their learning with these tools and what kind of things that they walked away with when they were using this curricula. From 2014, I jumped into the world of teaching online and doing online professional development through the form of MOOCs, or massive open online courses, designing those for teachers with the focus on teaching statistics through data and using a bunch of different cool tools, including CodeApp. And in 2016, I started here at the Friday Institute an effort that we call High Rise, a hub for innovation and research in statistics education. And it encompasses a variety of different projects where we are trying to provide the good foundations for our future data scientists. So one of the grants that also happened in 2016 is called ESTEAM, Enhancing Statistics Teacher Education with E-Modules. And in that grant, we're really kind of having three goals. We want to create online resources for statistics pre-service teacher education. We want to include it in that, and it is around expanding the CodeApp functionality, creating, capturing video of students doing things in classrooms, providing rich multivariate data tasks, which is going to be the focus of the conversation today, and doing video interviews with experts in stats ed. We're going to put all of those things together into modules and using different approaches, and disseminate those to different institutions that do statistics pre-service teacher ed, and implement those in teacher preparation courses and study how that goes. So my co-PIs on this grant are Bill Finzer, Stephanie Casey, Rick Hudson. We've got the research associate Jima Majika, and one of our current GAs is Christina Asme. And so I want to give a huge shout out to them because none of this is possible without a team.
And some of them are in your view there. Can you raise your hands and wave?
Yeah, so let's see who all is here. I think we know that Jima and Christina is here. And I think I saw Rick log in.
Yeah, he's logged in.
Yes, great. Great. Okay, so, oops, went too far. So I did mention CodeApp, the Common Online Data Analysis Platform. This has certainly been a huge effort coming out of the Concord Consortium that is sponsoring this webinar today, and a big effort from Bill to really kind of get lots of different projects and people together to kind of think about how to create a data analysis experience in an online free format. And so if you are not familiar with CodeApp, I highly encourage you to go to this website. We are going to use it a little bit later. And Bill, do you want to say just a few words about what CodeApp is and the efforts that are ongoing right now?
Sure. Well, it's most obviously an environment for exploring, visualizing, and analyzing data. But less obviously, it's a platform for other people to build on. And sometimes that takes the form of building it into courses. Sometimes it takes the form of modifying CodeApp to integrate into a website. We have 7 current funded collaborators, and we hope to soon have more. It's designed for students from middle school through lower division college. It's not yet a replacement for Fathom and Tinkerplots. It's more focused on exploration. It's being used by a lot of science projects. So the demand thus far, except for the ESTEAM project, has been with science education.
Mm-hmm. Great, thank you. Let me go back to sharing my screen. All right, so in your chat window, in the title, we call this data science, and certainly this is part of this ongoing webinar. And we can think about data science as science of meaning making with data. So just flip those words around a little bit. But if you were to complete this sentence, what would you put in the blank? So using what types of skills and understandings to create insight from data? And you can use more than one word, but what word or words would you put in that blank? So type that in the chat window, please. And I think in order to see the chat window, am I able to see the chat window and my screen at the same time?
I think if you pull up the chat interface using the top menu, Hollylynne, it's possible.
Aha. Okay. Yes, I got it. Thank you. Mm-hmm.
Nice variety.
That is a really nice variety. I see analytical several times. I see things like data organization, graphing, data organization, things like intuitive creativity, artistic. Yeah, some that are just saying it's a variety of different things, that one word just won't do it. Statistical thinking, yeah, computational thinking, computational computing, yeah. Well, good. I anticipated that I would, in mathematical, thank you, Bill. I anticipated that we would get different words in there, and I did that on purpose. So lots of people tried to describe data science using a variety of different diagrams. And my husband always teases me that educators always have to put everything into a Venn diagram to try to explain it. And so there are, if you just search data science Venn diagram, you will see a ton of them on the web. All right, different people taking their stab at trying to describe kind of what this is. But I think what we just illustrated from the exercise we just did was that it is a combination of a variety of different skills and understandings that you're bringing together in order to make insight from data. And that probably one, so for example, let me pick on the last word that Bill typed in was mathematical. If we just had mathematical skills, we probably would not be able to make insight from data. But if we have mathematical skills and we have some computational skills and we have some analytical skills and we have some statistical thinking, we might be able to put those together to help us make sense of data. So this particular diagram is one that is certainly out there, where they put kind of data science in the center. I like one that looks like this, where it's really kind of thinking about what different ideas are going or informing your work in data science, rather than thinking about data science as an intersection of things, of just trying to think about what skills and understandings one needs to draw upon in order to do data science. So this one comes from David Taylor, and actually in that blog, he presents lots of different Venn diagrams, and you can see that the title of his blog is The Battle of the Data Science Venn Diagrams. And this one is located towards the end of his blog as one that he particularly likes. And as I read through it, it kind of spoke to me as well. But to simplify things, what I like and what I want to draw your attention to is that we can kind of think about these, the scientific method, math, and statistics, is we might be able to group those under something called statistical and mathematical skills and thinking, right? That those kind of can work together. Thinking about a hacker mindset, being able to do visualizations, having some advanced computing skills, that those could kind of be grouped together as computational skills and thinking. Yep, I couldn't tell. Did someone have a comment?
I think someone has, someone is speaking unmuted who probably wants to be muted.
Oh, okay. All right. But if anyone would like to have a question or a comment, please let, in the chat window, let Talia know so that I can pause and give you time to come into the conversation. I am not opposed to that whatsoever.
There's a question, Hollylynne. What is hacker mindset?
So I think a hacker mindset is not being afraid to go in and try to see if one, you can think about it as see if something is broken, but also just being able to figure out how things work. So I think a hacker mindset is more of, I need to kind of put some things together, and I need to, you can kind of use the phrase, I need to kind of hack my way through it. I just need to be able to figure out how to piece things together, and of things that may not naturally come in one piece. So you can think about it as putting things together. You can also think about it as of taking things apart.
Great.
So with domain expertise, that's really, I mean, data science, data is always about something. I mean, when we think about engaging in statistics or engaging in data science, it's always about data. And that data has meaning, that data has a context, that data, we're exploring the data for a particular application purpose. And so that domain expertise is really understanding the context of the data and understanding kind of the application that you're trying to apply any of your data science skills to. So if you are in an accounting firm, and I had a gentleman in my class last semester who worked in an accounting firm. He was getting a master's in statistics, and he was really being paid to apply data science and statistics skills to help this accounting firm create, to mine their data and create different models for the accounting purposes that they had at their firm. So he had to understand a little bit about their needs and the context that they were applying it to. It was actually for an energy company. But he was applying his data science skills to help them solve that problem. Then this last piece is labeled data engineering, and that's really kind of the behind the scenes, the database, the system architecture of how data is captured, how it is stored, how it is accessed, and making sure that that is done meaningfully. There's certainly, I think, debate in the field as to whether a data scientist needs to have all of these database and system architecture, or are these two separate types of people who talk to each other.
Right.
And so in the work that I do, thinking about K-12 education and teacher preparation, I do not deal with this orange piece up here. That I'm not necessarily trying to prepare them. That's okay, we're getting a little bit of feedback in our room. We're gonna fix that in a second.
And your computer.
All right, sorry about that. Just checking to see if everybody was awake, you know. But I'm really trying to help build learning opportunities for students and teachers, where they're bringing together their statistical and mathematical skills in thinking, computational skills in thinking, and contextual and application expertise. So when I think about trying to put a task in front of students, there's kind of three critical pieces to it. There's the data that they're going to be involved in. There's the tools that they're going to use, and then the task that I'm going to actually construct to actually give them these learning opportunities. So I try to make sure that data is multivariate. It's large, and I put large in quotes because large, depending on your audience, is larger or smaller. That large is relative. That, you know, thinking about a data set of 30,000 cases is not something that I would put middle school students in charge of. But thinking about a data set of 150 to 300 cases, that's completely workable and doable for younger students. So large, I think, is very relative to the age group and to the experience level. But it sometimes can be messy. It might have missing variables. It might have different errors in it. All right. The context should be engaging. It has to be something that's interesting. And that's always a really tough thing because for example, I could put education data in front of teachers who would really care about salaries of teachers. But if they go and use that data set with middle school kids or even high school kids do not care how much salary their teachers make. That's just not engaging to them. All right. We think they should care about that, but they don't. So the context have to be engaging for your audience. Because you want them to be able to pull in, they have to have enough understanding of the context to pull in that third piece about the contextual expertise. And if they don't have, they're not interested in or don't have enough experience with that context, then they can't do that. So the tools that people should be using need to really facilitate transnumeration of data. And transnumeration was a term that was, at least to me, the first time I read it was from Wild and Van Cook, 1999, in one of their papers, and really kind of emphasizing how you take a piece of data, a numerical piece of data, and transform it into different forms. And so taking a piece of data, organizing it in a table is transnumerating it. Taking a piece of data and putting it into a graphical form is a form of transnumeration. So you want tools that facilitate doing that easily. And certainly over the last 17 years, 15, 20 years, that our tools to be able to do that have become much more plentiful and accessible, along with the idea of being able to visualize our data and being able to do computations. With the tasks, I really like to have multiple entry points so that depending on what levels of understanding and skills you already have, you can put those, you can bring those into the tasks and go where you are able to go with it. And so having those tasks that have multiple entry points is a hard to design, but I think a critical piece, and that you want them to provoke curiosity and being able to engage in envisioning different ways of how you deal with data. So to do that, the context that we're going to be thinking about today is thinking about investigating fuel economy of vehicles. So I'm willing to bet that the majority of us here in this webinar have a vehicle. We may, even though if we participate and partake with mass transit in our public domain that we live in, we probably still own a vehicle. Although that may not be true for 100% of us. And with that, we have to think about kind of our impact with that vehicle on the environment. And part of that is our fuel economy, how it actually processes and uses fuel. So if you have recently bought a car, or even a long time ago bought a car, you may remember seeing these kind of stickers that look like this placed on a vehicle. And they have different information on them, like your fuel economy of what you could expect, how many miles per gallon you could expect to get overall, how much you could expect to get into a city or a highway, how much you think you would save in fuel costs over 5 years if you bought this vehicle compared to other models. And they base that basically off of the annual fuel cost. So they give you a computation and they tell you what they use. I think it's quite funny that they do the annual fuel cost is based on 15,000 miles per year. It seems like a very low average to me, how many miles somebody drives in a year. But that is what they use for their annual fuel costs. And they're also, some of the more recent vehicles are now given fuel economy and greenhouse gas ratings, as well as smog ratings. And so these two aspects are new. I think that they were introduced in 2016 or 17. I can't remember which one. But those are relatively new. So what I'd like you to do, now we get to some of the participatory part of this. So hopefully, as I was talking about this, you perhaps started wondering about maybe some of the vehicles that you know about, or maybe a vehicle that you drive. So I'd like you to go to this website and look up a few, or look up at least one car. All right? This will take you directly to a web interface where you can put in the year, the make and the model of a car, and you will get some of the data for that car. So fueleconomy.gov/FEG, find a car. Let's see if I can, whoops, I'm sorry. Go back. And actually, Talia, I don't think I put this in.
It is, it's low on the, it's in the Google Doc.
Is it in the Google Doc? Okay.
Towards the bottom of the first page.
Okay.
Option 5.
Yeah. And Michelle also posted the link.
That's actually not the right, that's not the right page, Tim.
Okay, sorry.
No, that's okay.
There's a link available in the chat interface too. For
Oh,
everybody.
great. Thank you, Talia.
Actually, thank you, Michelle, but yes.
Yeah.
Yes. Oops, I keep clicking and going too far. So take a minute and look up a car and think about the kind of information you can get. Because oftentimes when we think about, start thinking about data, it's really important to think about an individual case. And by having students look up a particular vehicle, then they're starting to make sense of what a case is actually about. And so I like to have teachers and students kind of go and look up a particular car, whether it's their own or one that they know about, and look up the different information about that car.
Oh.
So would anybody like to share something surprising that they learned from looking up a case? And I'm going to stop sharing here for a second. Would anybody like to discuss what they learned about from looking up a case?
Well, I learned I saved $3,000 a year, or $3,000 per 5 years, compared to the average new vehicle by driving my 2006 Prius.
Ah, so Bill's got a 2006 Prius, and you've saved $3,000 a year. That's great.
No, every 5 years.
Oh, every 5 years. Sorry.
I've saved 6,000 total, I guess.
And we had someone here in the room, Jima, actually looked up, was it your car? Yes, looked up her car, and she spent $8,000 more than the average. So she hasn't saved a lick. She doesn't drive a Prius. Yes, Tim?
So I was a little surprised to see that for my car, the MPG equivalent is higher in the city than on the highway.
Ah, okay. Did anybody else see that in their vehicle, that the miles per gallon is higher in the city than it is in the highway? Okay. Yeah. So Glenn Kleiman is here in the room, and he shared that with his, he has a hybrid, and he knows that the city and the highway are exactly the same. So Tim, is yours a hybrid or not?
Mine's an electric.
An electric, okay.
There are a couple of comments in the chat interface too. Michelle writes, I looked at Priuses for the past 20 years. The fuel cost went down, but then back up. it was surprising because I thought they'd get more efficient, but they aren't ordered well on the website, so it might be a spurious observation.
Nice, nice. So start not just looking up a single car, but looking up a car over a particular time period.
And Sherry Gardner also writes, fuel efficiency is somewhat based on the price of fuel and capitalistic reasons. So when fuel is cheap, they are less efficient, and when fuel is expensive, they are more efficient.
Yeah. So obviously the price of gasoline that they're using for their computation matters a lot.
Interesting.
Nice. All right, so I would claim that we at least have a modicum of domain knowledge and context expertise that we can now think about some data. So let me go back to sharing my screen. Whoops, I'm really bad at that. Okay, so if we think of it about going beyond a few cases, I wonder if we looked at data for many vehicles, what could we learn about the fuel economy in vehicles? So, getting, again, kind of thinking about getting students hooked into the context and understanding the context through looking at a few cases, but then thinking about, okay, well, if we looked at data for many different vehicles, what might we be able to learn about fuel economy? So that is what we're going to engage with today. And I'll get to explaining this a little bit more when I get to the different options of how to look at the data. But in many of the options, I have condensed the data set to only have 16 attributes in it. And these are the attributes that we're going to be looking at. And you'll notice that some of these attributes are quantitative in nature, like the city miles per gallon. Oops. Gravy. The highway miles per gallon, thinking about the number of gears, which would actually be the way that they have number of gears or number of cylinders. Even though it is a number, there are kind of distinct categories for that. And there are the annual fuel cost is certainly a quantitative variable there. But then we also have categorical variables like whether or not it's a hybrid and what kind of vehicle it is, whether it is a car, an SUV, a minivan, or a truck, for example, what kind of transmission it uses. Is it manual or automatic? And then within manual and automatic, the detailed transmission tells us a little bit more about that transmission type. The drive description, whether it is a two-wheel, four-wheel, or all-wheel, and the type of fuel that it uses. All right, so we have several different variables in here that we can start to take a look at. So now is where we're going to go into the Google Doc, and we're going to kind of explore explore the data, and we're going to all start with option 1 so that we can take a look at that. So I'm going to actually go into the Google Doc. And option 1, so here I am, I just highlighted where we are in the Google Doc. This is a random sample of 300 cases. And what I did is I downloaded this data 2 years ago. And so I have 2015 data. And though I probably should go annually and update all of my data, I have not. So we are looking at the 2015 data rather than the current 2017 data. But if you click on this, this link, it will open up a CodeApp document. And what it's doing when you click on this link, this is a shared link to a CodeApp document where now each of you have your own copy of this document. So we're not all in the same space together. We each have our own individual copy, which also means that at the end of this, if you want to save your own personal copy of this document, you can. Okay? But what you do in this document is not going to affect what anybody else sees. And I've ordered our discussion today with the different options of going from very kind of pre-structured experiences for students to being more and more open-ended, okay? So I have used this particular version of the 2015 vehicle data. We did take a random sample, so this is a simple random sample of 300 vehicles of all the vehicles that were manufactured and logged in the federal government website. So of that 300 sample, I pre-created 2 graphs, and then I have a text box here that has a brief description of what the graphs are. And if you scroll down to the bottom of that, you can click on next page and there'll be a couple questions to consider. But in this document, I already have a few of the variables represented for you. So if we think about this first graph, we have the city fuel economy. So this is how many miles per gallon I get in the city. I have that on my x-axis in this first graph. And for my transmission, I have whether it was a manual or an auto. And I overlaid a third variable. So one of the really important things about using multivariate data sets is that you actually use multiple variables. And so I have a third variable overlaid, and they are colored. If they're not a hybrid, they're blue. And if they are a hybrid, they're colored as like a, I don't know what color that is. It's kind of like an orangey red. Yeah. Let's see. And my screen thinks that I am not participating. Hold on. The screen just got very low. I don't know what just happened. My screen was acting like it was going to go to sleep.
It was fine for us.
Okay. I just didn't want my computer all of a sudden to go to sleep.
It's still fine with us.
Okay. All right. So this is what I have displayed in this first graph. So if you think about it, I've got the distribution of this one variable city, miles per gallon, separated so that I can compare the groups by categories, manual and auto. And then I have another category of hybrid being yes or no. And so actually when we were looking up cases, those of you that shared, a few of you had hybrids, or in Tim's case, he had an electric one. And electric ones are not represented in this data set. Only the ones represented in this data set are those that use fuel at all. So if it's electrical and it uses fuel, it would be in here. But if it is a complete plug-in, it would not be represented in this data set. With our other graph over here, I have the city miles per gallon with the highway miles per gallon. And then I overlaid the number of cylinders in the car. So those, yes, is there a question?
No.
No, okay. So I want to give you a few moments to take a look and see what you notice about fuel economy. I have, as I said, I have these 2 graphs pre-created for you. If you start clicking in graphs, you'll notice that they are linked together. I can click down here in my legend, so I'm clicking on number of cylinders right now, and you'll see that it actually selects things across the different representations. Clicking and dragging. I can also go over here in my table and I can scroll through my table, and perhaps I want to find a particular vehicle. If I wanted to look at this particular vehicle, I can see that, oh, it's a Toyota. It's a Prius. Bill, how did I know you rode a Prius? And if you click in a graph, under this menu over here, if you've never used CodeApp, if you click on the ruler, you'll see that there are different kinds of measures that you can add to your graph.
That and mean did not appear.
So I want to give you about 2 or 3 minutes of playtime with this data set, and think about what you are learning about fuel economy first and foremost. But in the back of your mind, let's go metacognitive and think about what kind of skills related to data science might you be having the opportunity to be learning, right? So as you're investigating, first of all, investigate the task about fuel economy. What might you learn about fuel economy? But in the back of your mind, kind of keep track of potentially what you might be having an opportunity to learn about related to data science. I'm going to give you 2 minutes of playtime, because we can do thorough data investigations in 2 minutes. Cool. Okay. So we weren't able to do a thorough investigation, so we might not have any large claims to make about fuel economy for these vehicles in 2015. But I'd like to hear a little bit about some of the things that folks explored and what they may have noticed about fuel economy.
Go ahead, Tim.
So one thing is I dragged drive_desk into the middle. And you can see on mine anyway that the most fuel efficient cars tend to be 2-wheel drive front. And interestingly, 2-wheel drive rear seem to be less efficient.
All right, so tell me that again. Tim, you took drive?
Drag that one into the middle.
Into the middle of which one?
Of the left-hand graph.
Okay.
Okay, so the first thing that happens is, unfortunately, we see that 2-wheel drive front and 4-wheel drive both look very much like the same color. So since I have CodeApp skills, I changed the color of 2-wheel drive front, which you can do there, and I made it kind of orangey. And so now we can see, oh, look how all the orangey stuff is towards the right-hand side, both on the top and the bottom panels of that graph, suggesting that lots of the high-efficiency cars are two-wheel drive. But I'm also interested in the two-wheel drive rear, which is the kind of car I grew up in. And those are more towards the left, ignoring all the other kinds of drive.
Okay, nice. Nice. Would anybody else like to share what you perhaps explored and noticed?
Don't be shy.
The top 5 fuel saving cars, which are sort of in a class by themselves, are all automatic transmissions. I didn't necessarily expect that.
Oh yeah. Expected like the top 10 or something, yeah.
The top 5 though are really almost outliers.
So these ones right up here?
Yep.
Yeah. Yep, they're all automatic.
And I mean, you can see that on that graph clearly. I actually discovered it on the other graph just by selecting those 5 points and then noticing where they were. Yeah.
So you started by selecting the ones on the scatter plot.
Yeah, saying what's different about those, what makes them so great. And there are some things I might have expected about that. Maybe they're all electric, but I didn't expect that they would necessarily be all automatics. I don't really think of automatic as the most fuel saving cars, and you can see that on the low end they're not. So
yeah, very nice.
Hollylynne, Michelle writes, I don't know much about cars, but it seems like ENG_DISPL, which tells you the amount of air displaced by pistons, should be an indicator of aggressive consumption. But enough of the more efficient cars had enough of these values that I need to reconsider that expectation.
So I'm going to take engine displacement. So engine displacement, I now have that over here on my right-hand scatter plot. So engine displacement does tell us about the volume of air going through the cylinders in your engine. And so it is measured, it is a measurement of volume. And so you can imagine that those that have less volume of air going through the cylinders have less cylinders. So when you have a car that has 8 cylinders in it, it's going to pass a lot of air through it to go through a cycle, where an engine that has a small number of cylinders is not going to have that much volume of air going through it.
So I found, for myself, one of the things I found useful to do here was, for example, if I went back to the table and I changed certain things to categorical, like number of gears, for example. Can you find number of gears?
Let's see, where is that? Number of gears.
And then change that to categorical. I did this.
I'm going to edit the properties here, and I'm going to change it to categorical.
And then drop that one into the middle of the far right graph.
Okay.
And so now I find it easier to distinguish both for gears and number of cylinders, something like that.
Yeah, treating it as categorical.
And an interesting thing here again, you see where it says 1 gear, I'm assuming that's continuously variable transmissions. Tells you something about their efficiency. And then an interesting thing there is they seem to all be up on the high end, and then there's a cluster of 3 there. So that of course gets me interested to see, are those like SUVs, and what kind of cars are those? Are they hybrids, non-hybrids?
Yeah, so let me see if I can select one of those, and let's find out who that sucker is. This one is a Nissan Quest, and it is it's a minivan.
Yeah.
Let's see what
it's continuously variable something.
Yeah, and this one's an SUV, so nice. And that's a Jeep.
I found myself thinking about confounding variables a lot.
Uh-huh. Can you say more about that?
Well, those points in the upper right of that rightmost graph, there's a lot of things that are true about them and it doesn't seem like any one of them is what brings them up there. Or I don't know, I don't trust that it's number of gears or that they're hybrids, or there's so many different things that could explain why they're up there.
Uh-huh, or a combination of things.
Mm-hmm.
Yeah, yeah, nice. So that, you know, starting to think about, again, because we have a multivariable data set, we're able to explore different variables, and then this idea of what is impacting what, and the fact that it might not just be a single thing impacting, starts coming into play. So what I'd like to do is, if we scroll, if we are back in the Google Doc, and after the different 5 options, I have in red a link to a Padlet. And if you click on that link, what I'd like to do is to, interesting, my option 2 is not in the right place. So here is option 1. This was our table of 300 and 2 graphs pre-created. If you could click on a plus button underneath in the column that's labeled option 1, and just write a few things about what you think the learning opportunities were related to data science, what we just did. So this was a data. We had data displayed in a table, and we had 2 graphs already pre-created using several of the different variables. And what were the learning opportunities related to data science that we had available to us?
Padlet thing is cool. Never seen that before.
Yeah, this is one of my favorite kind of teaching tools to get folks to put stuff up there and organize ideas. Yeah, now even though we did not add any measures to our graph, we certainly could have. So what we were just discussing, we did not add, for example, a linear regression line over to the scatter plot, and we did not add means or medians or display things in a box plot over in the right hand. But we could have, and probably some of you did. And those might also help us to tell stories from this data as well. So I just wanted to show those things just in case. Yeah, we're going to remove gears here for a second.
Well, another interesting thing on the right-hand graph, by the way, is to add y equals x.
Yes, so I can plot a function here. And my function is being displayed in red. And so I can think about, you know, so I think that was Tim who just spoke, that with y equals x, I would assume then that the city and the highway are the same, which I think is the context that Tim was sharing that was true in his car, that city and highway have the same miles per gallon. And by plotting that function, then we can think about which vehicles are above that line and below that line and why. Nice. So we can apply a mathematical function here that has meaning in the context of our data, and then think about our data point in relationship to that mathematical function.
If you drop hybrid into the middle there, you'll get 2 lines, one for each type of vehicle.
Mm-hmm.
And then because I overlaid that, I got to see all of them. And you get to see like the category with a number of years. One of them looks really different than the other. Most of them are pretty close, even though the number of years are different, but there's one that looks a little bit.
So what Jima was sharing here in the room with us, looking at number of gears, if I overlay number of gears, I notice that the number 1 here has a very different slope than the others. All right. Nice. They're also kind of messy and we can't read those, Bill.
Yes, Bill. Fix that.
Yes, Bill. We can't read those.
That's the cue.
So anyway, good. So let me go back to our Padlet. So we see the ideas of multivariate visualization, being able to link representations, being able to filter data, adding new or different variables, so by coloring points, okay? And so we were able to jump right in and start kind of exploring. Depending on the skills that one had, both in thinking about data science as well as with this tool of CodeApp. So I would like to hear from someone on how they were able to jump into this who was a non-CodeApp experienced person. What entry points is there anyone in our group today that would like to share? If you've had very little CodeApp experiences, what were some of your entry points and the things that you were able to do in looking at this data? So I'm just going to put words in people's mouths. I would claim that someone who is a relatively novice CodeApp user, because those graphs are pre-created, if I just spend, the 30 seconds that I spent before saying, okay, you can click in here, you can highlight a case. One of the first things that I did was to highlight the fact that the data was multiple linked. And just by doing that, I think that allows some exploration around individual cases. That if you're a relatively new user, and even those that were experienced users, we were first drawn to those cases that looked different. And so oftentimes our early exploration is around looking at those novelties, those oddities, the things that kind of draw our attention. And we're looking for specific cases, and we weren't necessarily trying to describe things in the aggregate at this point to say, well, all of the autos, the auto transmissions do this, or all of the manuals do this. We were really looking at individual cases or groups of cases together. And oftentimes in how this differs in statistics is one of our goals in statistics, and it's a worthy goal, is to get our students to think about distribution in the aggregate. And while that's incredibly important, and we want to be able to make inferences around being able to say things in the aggregate, if we jump too quickly to that, we lose some of the exploration around what's interesting in a data set. And so I really think that having this opportunity to look at this data with graphs already pre-created for you can afford that opportunity.
I'll point out though that students don't necessarily discover the clicking and selecting, and so it is important that you demonstrated that for us.
Yeah, I absolutely agree. And I've had that experience. That's why it's one of the first skills that I teach someone in any kind of dynamically linked environment is to show them how things are linked. I agree with you. So, all right. So now let's go to option. So because of time, we're not going to go through and walk through each of these different options. So what I'd like to do is to give everybody about 5 to 7 minutes. I'm going to tell you what the other options are, and you can decide based on your skill level and comfort level which option you'd like to explore, okay? So option 2 is this exact same data set of 300 cases. There are no graphs pre-created, and the data is shown in a hierarchical table, meaning that one of the variables is moved to the left of the table, and it creates a hierarchical structure, so that the data is organized around one of the categorical variables, okay? So that's option 2. In option 3, I have a set of, instead of doing a sample of 300 cases, I took the entire data set and I have 100 different random samples of 100 cases. And so, actually, it was my husband who used Mathematica to generate these random samples for me. And each of the CSV files, I have a folder of all 100 of them, and you can drag any one of them and drag it into CodeApp. Okay. So I am going to illustrate that just in case anybody wants to explore dragging a CSV file into CodeApp. And just for full disclosure and for educational purposes, I have a link to a document that has the code that was used in Mathematica to actually generate those samples. Because that's also, if we think about data science skills, something that we might, even though in this case the teacher used those skills, we might want students to use those skills as well. Option 4 is a full cleaned data set of the 1,226 vehicles with the 16 attributes that we have already looked at. So it's the same number of attributes, but all 1,226 cases. And then option 5 is to go to the website and get it yourself. Go to the website and download the whole shebang from Fuel Economy website that has lots of different variables in it, all the different cases. You can download it into a CSV file and see what you can do. Okay. So before I let you go, for those that have not ever looked at putting a CSV file, I am going to go to this folder that has my different random samples in it. And when I used this recently in an AP statistics classroom, we used a random number generator through Google for each of the kids to randomly select one of these random samples. And so every kid in the room had a different random sample. And so I'm just going to scroll down here and pick one and download it. So now it is on my, oh, it says that it's failed. Why not? Why is this failed? Let me make sure I have this shared. Can view it, so you should be able to download it. Let's try this again. Is anybody else following along?
Let's see.
You were?
Forbidden.
So let's try somebody not on our team. Right. Bill, can you try this for me? Can you try downloading one of these and see if it works for you?
I tried downloading the big one, and that seemed to work.
Okay.
I'm downloading 09 just fine.
Okay, so it's something on my machine. Yay, isn't that fun? Yeah, it's saying it's failed forbidden.
Yeah,
Good gravy.
Mine worked fine.
Okay, well, normally what I would do is I would download that CSV file and then open up a new, so if you are in the Google Doc, here's a link to a brand new CodeApp document. Oops. Okay, I failed there. That's not a brand new CodeApp document.
Huh. No, it's not.
I was getting link happy and did something wrong. Let's see.
I just got it.
Let's fix that.
Oh, right. Nothing appeared in mine, and I was waiting for something to appear.
Okay, now that should work.
Yes.
All right. So I'm going to create a new document. And normally I would be able to take one of these CSV files that were down here in my downloads and just drag it into the window or something that was out on my desktop. But what I can do in here is, because I have, oh, I know what's going on.
Oh, wrong identity.
I had the wrong identity in there.
Okay.
Let's see. Now let's try to download. Yay. All right. Let's go to a blank CodeApp, and then I'm just going to drag that car sample in there. And there we go. There's car sample 22. Okay. So now that I have hacked my way through showing you how to do that.
Well, so that's what hacking means.
That's what hacking means, is figure it out. So I apologize for that blundering there, folks. But take a couple minutes and explore one of these options. And again, it's the same data set. You might have a smaller sample size if you choose one of the samples, or you might have a larger sample size if you're using the 1226, or you might be going out to the website and trying to get this data yourself. But again, think about the learning opportunities in data science that you're having with this. And I'm going to be quiet for a moment so that you can engage. Oh, drag it to the left, sorry. So after you have explored a little bit, if you will go back into the Padlet, and in the column associated with the option that you chose, if you'll write down some data science learning opportunities that you had by exploring that option. And I'm going to go back to sharing my screen that has our Padlet on it so we can see what some of you all are contributing here. So I'd like to talk a little bit about what I see being added to the Padlet. This idea of thinking about moving from the case to the aggregate was mentioned underneath option 2. And while it was only mentioned under option 2, I think that there's opportunities for that in any of the different options. I think anytime that you have a data set that has a significant number of cases where you're trying to describe something, that you have this, you have an opportunity to push students to go from the case to the aggregate. And sometimes it may not happen naturally. It's going to come from the kinds of questions that you pose, either that you pre-plan to pose, or that in the moment you push them towards trying to make a claim that's about the entire set of data that they have at hand, or trying to even generalize and infer something beyond if they happen to have a sample. I think that it's related to what I see underneath option 3 about the comparison of samples. That when in a classroom setting, you have students using different samples, and they're noticing, they could be noticing similar things or very different things, exploring a particular question or a particular measure. There's an opportunity to actually gather across samples particular measures in this idea of a sampling distribution. I will share that in that AP Stack classroom, when I did this lesson, we were actually looking at building up inference around linear regression. And so they each, at one point in the lesson, they gathered, they did a least squares regression, and they, in a Google form, they each inputted the parameters for their equation, their slope and their y-intercept. And then I was able to then grab all of their slopes and create a distribution of their slopes and try to think about, okay, well, look at how much our slopes differed in with the different samples that we all had. And if we want to think about what might we expect for there to be a slope, we actually had the conversation about y is equal to x. And is that a comparison that we're trying to do? If there were no relationship between, we were looking at city and highway. If there was no relationship between city and highway, what would we expect the slope to be close to? You know, we would expect it to be close to 0. And so is our slopes, are they anywhere near 0 or are they not 0? You know, so it was some really nice kind of conversations, and we were able to do that because everybody had a different sample. And so that learning opportunity came about because of that. I think it's pretty rare in a class where teachers will give everybody a different sample of data. So the hierarchical table, back to option 2, the comment about easier to apply to new situations. I'd like to further understand that. What is easier to apply? Okay. Okay. Got it. Got it. Got it. So what was being shared here in the room at NC State was the idea that after going through option 1 and option 2 and having this experience, that this was helping this teacher kind of think about, I could apply these skills as a teacher to create new situations and with different data sets for their own use and their own practices. Nice. Those that explored the full data set of 1226, I like the comment about how much more do we get, that the sample of 300 seemed to show the data stories just fine. That, you know, what do we gain from having a sample, or what do we gain from having the whole data set? I mean, in a world of big data, should we ever take a sample? If we have access to all of it, should we just not use all of it? You know? Well, maybe not. You know, maybe for some learners, it's too overwhelming to be using that much data, and we can also teach them about sampling techniques, and that if we take certain kinds of samples, that we can still get a lot of different information, and that can help us with inference. There's often, I think recently, kind of a big debate, particularly around the introductory statistics course, is we have spent so much time over the last decade trying to think about doing different approaches to inference in that intro stats class. And now with big data, do we really need these inference skills? If we have all the data, so let's just use the data and make our claims based on the entire data set. Do we really need to actually infer anything from a smaller data set, from a smaller sample? But I think that can still be quite useful, because there's lots of opportunities where we don't have access to the entire data set. And so even if we get a data set that we think is complete, it might not represent everything that is out there, or that we could have access to. And then it looked like we had a few people that looked at downloading the raw data. And so you had to change the file format of the downloaded data. If you do get the data set open, you see that there's lots of variables, so that there is this real need to kind of clean the data. And again, we have to think about, as far as our learning opportunities for our students, when is it the time to give them that learning experience? And depending on your objectives, having students go and download raw data from the website we were just at, and have to clean all of that while I claimed that they would be learning some nice things, it might take way too much time before we get to the other things that I want them to learn. Right. And so we have to have that balance. Now, if they're in a particular type of course where learning to deal with raw data is really important, and learning those data management and data organization skills and cleaning skills are important, then absolutely we need to include those experiences.
There is the paradox, though, that as soon as they go out and try to do anything with real data, they will experience the need for these skills.
Right, I agree.
So it's like if we don't prepare,
we have to include it somewhere.
Yeah.
Yeah.
Yeah. And I think this might be particularly true for teachers who are trying to get interesting, authentic data for their students.
Yes.
So
it's a data science skill for a teacher.
Right. Because you say, I want these things for my kids. I know my kids don't have the patience and I don't have the class time to do this, but I, as the teacher, might need to know how to go through and strip out all the commas and put them back in appropriately and all the different things you might have to do.
Yep, absolutely. Yeah, so hopefully we were able, oh, and I just wanted to also draw the attention to, somebody asked about formulating a meaningful question, and that he or she was kind of meandering around at first, but then eventually came up with a question. Asking good questions of data is a fundamental skill that we have to be engaging our students in. So we might start with where we're posing some questions. We might start where there's some of these open exploration, like, well, what do you notice? Here's a data set about fuel economy. What can you learn about fuel economy? But as you are starting to explore different variables, a more focused question might be in your head. And getting them to actually formulate that question and make it explicit is an important skill that we want them to learn as well. That way, we can help them think about what variables are really needed to answer that question. Do they have the data they need to answer that question? Certainly, students will sometimes ask a question and I'm like, well, can we really answer that with what we have at hand? And we might not be able to answer that with what we have access to at the moment. And so let's table that question and let's ask a more refined question that we do, that is answerable with our data. So. Nice.
You have to
Okay. Can I add something to that?
Absolutely.
So I had trouble with my students and trying to formulate questions as well. And one strategy I came up with that I'd like to share is sometimes asking students to come up with a claim instead of a question can be easier. That is, can you come up with a statement that you think is a true or maybe even a false statement about the data? Gas guzzlers cost more, is a claim, and then maybe you can make a visualization that supports or refutes the claim, and that might help lead you to the question. That is, sometimes I think students find the question somehow seems fake or bogus or something like that because you're trying to force what you're thinking about into this strange
question format
before you're really ready to do that.
Right. Yeah, that's very nice. I like that. And it does make it much more tangible for students. Okay, so so we've looked at the Padlet. I want to show you a brief video it's an animation that we constructed based on some real students. And let's see, I think in order to do this, I need to turn on my audio options to have, let's see, I think it is the computer audio. I think this is going to work. Let's see. Well, I'm just messing everything up.
Did you set the checkbox in the screen sharing dialog that Zoom brings up? There's a checkbox for audio.
That's what I was trying to find. All right, let's try to share again and share computer sound. Perfect.
That's the one.
That's the one that I was looking for. Yay. All right, so take a look at what some students can do with this task and how a teacher might actually facilitate a discussion around the students' work.
In this investigating vehicle fuel economy task, we will use a random sample of 300 vehicles manufactured in 2015. Most drivers are interested in fuel economy. In this activity, you will see the sample of 300 cases, along with 2 graphs that each show 3 variables. You will explore the data by clicking on rows in the table, on data points in the graphs, and on legends for different categories. Explore different measures using the ruler icon. We will use the common online data analysis platform, CodeApp, tool, a free online data visualization and analysis tool in this investigation. What did you learn about fuel economy for these vehicles? Bill, what do you think?
The fuel economy of the hybrids looks different than the other vehicles.
Tell me more. In what ways are the hybrids different? Where are they located?
There is a group of hybrids that live outside the clump of all of the other vehicles. 5 of the hybrids get more miles per gallon in city driving than all the other vehicles. You can see this in both graphs.
So, Bill, you are saying that some of the hybrids have higher city fuel efficiency, and you can see this in both graphs. Did anyone notice ways that hybrids are similar to other vehicles? LeBron, will you share your thinking with the class?
Hybrids have the same number of cylinders in their engines as the other vehicles.
How do you know? What is your evidence?
I clicked on yes to see hybrids in the graph comparing the city fuel efficiency for automatic and manuals. The table showed that hybrids all have 4 or 6 cylinder engines. So, I clicked on 4 and 6 cylinder engines in the legend of the scatter plot comparing city to highway and noticed that most of the vehicles were highlighted in both graphs.
Keiko, will you share what you learned about fuel efficiency?
I compared the miles per gallon in the city for automatics and manuals. I looked at the average.
What do you mean by average?
I used the ruler tool to find the means. Automatics have a mean of 20.15 miles per gallon, and manuals have a mean of 22.31 miles per gallon for city driving. I also compared their medians. Automatics have a median of 19 miles per gallon, and manuals have a median of 24 miles per gallon.
Can you say more about your thinking?
Well, when I compared the means, the manuals have better fuel efficiency than the automatics in the city since their means are higher. Also, the fuel efficiency is better when you compare their medians because their medians are higher. So, I think that the manuals get better gas mileage than automatics in the city.
Do you think that the mean or median better represents the fuel efficiency? Can you explain why?
At first I was going to use the mean, but it looks like the automatics have a tail on the dot plot that shows some of those cars get way better gas mileage than the others. So, I thought the median would be better for comparison since the fuel efficiency for those cars would have a greater impact on the mean.
What do you think about that? Do you agree or disagree? Helen?
I agree with Keiko that manuals are more fuel efficient in the city.
Tell us more about your thinking.
I do agree. Manuals on average have better fuel efficiency in the city than the automatics, but I think that hybrids outperform most other vehicles even though they're automatics.
Tell us more.
I can see it in the dot plots and scatter plot. The median of the manuals is 24 miles per gallon and the hybrids all perform between 24 miles per gallon and 53 miles per gallon. All hybrids outperform the top half of the manuals. The worst performing hybrid gets more miles per gallon than the average automatic or manual when you compare medians and means.
Who can add on? Tamar?
I also noticed that some cars get way better fuel efficiency in the city and those cars are hybrids. I saw this in the dot plot. Hybrids get better gas mileage on the highway, too.
What convinced you?
Looking at the scatter plot, I can see that vehicles that get better gas mileage in the city also tend to get better gas mileage on the highway, as the miles per gallon increases on the x-axis, which shows us fuel efficiency for city. The miles per gallon on the y-axis, representing highway, increases, too.
Tamar, can you tell us about the model that you found to describe this relationship?
I wanted to find a model for all the vehicles. I used the ruler tool to overlay a movable line on the scatter plot. I dragged the movable line to adjust the slope and y-intercept, until I got highway fuel efficiency equals 0.903 times city fuel efficiency plus 8.3. Then, I opened a new graph.
Can you explain why?
Even though the hybrids show a positive relationship like data that represents all of the vehicles, they really outperform the other vehicles in terms of fuel efficiency. So, I wanted to show this with a different line. I drug city fuel efficiency on the x-axis to represent my predictor variable, and I drug highway fuel efficiency on the y-axis to represent my response variable. I wanted to find a line that best fit the relationship among the hybrids. I ended up with highway fuel efficiency equals 0.61 times city fuel efficiency plus 16.
So one of the reasons I wanted to show you this is that I think there's one way of us kind of engaging about in what students are learning about data science whenever we're engaging in these tasks, but actually seeing what students are capable of and then thinking about what would I do with all of that as a teacher. So I think one of the scary things about having students have experiences with data, just how I made the comment that often we don't see teachers give students different samples of data. Well, even giving them all the same sample, but letting them explore in different ways to come up with what they might notice or to make a claim about something can be scary for teachers because you can't necessarily anticipate exactly what all your students are going to do. Not that we can ever exactly anticipate that anyway, but it seems even more scary when you're dealing with a data set. So one of the things that we did in trying to create this video was to show how a teacher might orchestrate a discussion and really try to think about that, starting with, if you noticed in this video, that the teacher started with a student who went from kind of a less sophisticated way of the kinds of statistical tools that they were using to analyze the data to a much more sophisticated way of thinking about it. And so, he sequenced the discussion so that the students' work was kind of building on each other. And that's going to come from a teacher who's able to kind of walk around and see what the students are doing. And kind of then thinking about, okay, if I want to tell a bigger story as a class and get my students engaged with this and hear different voices and not necessarily just jump to some highly sophisticated way of thinking about the data, how can I sequence this discussion and have them build off of one another? So we're hoping that the videos like this might also give teachers some ideas of how this might work.
So how do you think your increased interest in data science education has changed the way you're building materials for statistics?
Oh, I think that it has changed a lot. When I look at some of the things that I wrote, so first of all, this vehicle data I have been using since 2006. When I was creating some curriculum materials for teachers. And I went out and got data, and I picked particularly interesting cases. I didn't even do a random sample. I picked particularly interesting cars because they would show different mathematical and statistical concepts best. And I chose 41 cases, and I constructed a data set that had maybe 6 or 7 variables in it. And so it did have more variables than what you might typically see, but it only had 41 cases in it. And there was the kinds of questions that I tended to ask were much more focused on getting students to understand, for example, well, is mean or median the best measure of center here to use to describe this distribution, and not necessarily connecting it back to the context as well as I should have. So I think not only has my appreciation for thinking about using multivariate, multi-case data sets with students, but the kinds of questions that I get them engaged in, both students and teachers, has changed a lot. So I don't ever put so thinking about materials for teachers, I can't even remember the last time that I put a single variable in front of a teacher, or even two variables in front of a teacher. And I also can't remember the last time I used something that was less than 50 cases. So. And there's a lot more open exploration. So instead of starting off by me asking a very focused question and leading them down a path, I almost always start off with, well, play around with the data and tell us what you notice. Pose some questions for yourself that you're interested in exploring.
Let me ask this question of you as a fellow curriculum developer and data aficionado trying to incorporate more data. One of the perspectives that we take when we use CodeApp or one of these dynamic data analysis platforms is a sort of case-centric, where a dot represents a case. And as you mentioned earlier, it's really important that students understand what a case is. In these data, again, my students would often be saying a case is a car, but in fact, a case is a model of a car. Do you care? Does it matter making that distinction?
For early learners, I don't think it does. I mean, I think the distinction is that the case is what we happen to know about this vehicle. So the case is not the vehicle itself. It's not the Prius that's sitting in front of us. It's the things that have been measured about that Prius that we're able to know something about that Prius, to describe that Prius. It's not the Prius itself.
But it's interesting, isn't it, Tim, that it's already an aggregate?
Yes, and one of the places where we get fouled up with this is that if we try to ask questions about the population of cars that are on the road, oh, so how much gas does all of the United States' cars use in a year? We can't use that average in order to estimate it, because it's not weighted properly by the number of cars of each model. Right.
Yeah, so I can't use my model from the 1226. Is that what you're referring to, Tim? To answer the question about the US, because there might be more Priuses on the road than there are Hummers.
Maseratis.
Right.
So, but there are lots of Ford F-150s, more than there are Priuses, I think. And, that opens this can of worms to another type of question, but one that students might be really interested in. And then we have to be cautious. But I so don't want to go down that road when I have this nice data set.
Well, but I think it poses an interesting question of, well, if you were going to put it back on the students, well, if you were going to answer that question, how would you go about it?
Good. Yeah.
So if you wanted to know something about the fuel consumption or the annual fuel costs of all the cars in America right now, how would you go about answering that question? What data would you need? And even if they don't end up getting access to that data, they can go through the exercise of thinking about, well, what data would I need, and how would I go about either finding it all out or getting a sample of it?
So we just have 5 minutes left, and I bet there are some people who've been holding off asking a question that this would be a good time to go ahead and ask that question. And if you have audio available, that's the easiest way to ask it. It certainly has been thought-provoking for me. I bet, well, I really don't know what disciplines people in this webinar are coming from. And you, Hollylynne, are primarily from the statistics and statistics education discipline. Have you thought much about science education and how to combine science, data science education with science?
Have I thought much about it? A little bit, mainly through my conversations with science educators who are engaged in data science. But it certainly isn't something that, because even though I'm situated in kind of statistics education, really at the core, I'm a mathematics teacher, educator, and researcher. And so I'm situated in that discipline of thinking about mathematics, what happens in K-12 mathematics teachers' classrooms. And right now in the K-12 curriculum, there is some statistics in that curriculum. And so that's where I'm mostly situated. But one of the things that I try to think about and trying to push others towards is that because data science, a huge piece of it is about the contextual understanding. So the context can be, I mean, in mathematics, our context is not math. We have other contexts. And so the data can be science related, it can be social studies, history related, that it's multidisciplinary. Data science is not one of those things that just belongs in a math classroom. And I think I've had to push myself kind of beyond that, where I was 10, 15 years ago when I was thinking that, okay, well, statistics is in the math curriculum, and so that's where I'm gonna think about it.
Yeah. Did you have any closing thoughts?
I think just something about, let me share my screen again so I can go back to the Google Doc, just to let folks know that in the Google Doc, oops, what I wasn't able to get around to sharing is some examples of discussion forums where I have used option 1 and option 2, and what teachers actually learn from engaging in those. So I showed you, I chose to show the video of a teacher kind of orchestrating a discussion around students' work rather than showing you the discussion forum data, because I felt like we had captured a lot of the stuff already in our discussion. But if you're interested in seeing what teachers who, I think pretty much everybody in these discussion forums, it was their first experience ever using CodeApp. And for many of them, for example, in thread 2, which I labeled I hated stats, the whole thing of that discussion is I hated statistics, and now I might not hate it so much because of what I just experienced. Or I wouldn't have hated it so much if my experience would have been more like this. So I think that if you're interested in kind of thinking about some teachers' perspectives beyond kind of what we just experienced here today, you can go through that discussion forum data.
Great. Talia, I think you had a few things you wanted to say at the end, is that right?
Yes, I think I'm ready for that step.
Yeah, go ahead, I'll stop sharing.
Okay. Excuse me, I just need a second.
This has been wonderful, Hollylynne.
Okay. Okay. So thank you again, Hollylynne. I had a terrific time in this webinar, and thank you everybody for joining us. If we did not get to your question, or you would like to leave additional questions in the Google Doc we shared, please go ahead and do so, and we'll leave you an answer in the Google Doc tomorrow. We had a lot of great interaction, and I'm grateful to all of you for making such rich discussion happen. We will send you a link to the recorded session shortly via email. And if you enjoyed this webinar and you would like to attend future data science education webinars, Tim Erickson will actually be our next host and sitting next to me. Thank you, Tim, for waving. You can sign up for Tim's session at concord.org/meetup. You can also stay connected with us on Twitter at CodeApp DataSci. If you use the hashtag DataSciEd to tweet us any additional questions or resources, we'll be happy to respond to you as well. Please feel free to visit our website, codeapp.concord.org, to connect with us as well. Thank you again, and we will see you all next time.
Bye.
Bye. Thank you very much. I really enjoyed this.
Hollylynne, if you want to stay on for a few minutes, we can debrief.
It's Dan. Hi, Dan.
Sounds good.
Joshua. So Joshua, where are you that it says S?
I am from, Tim, you were, this S right here, right?
Yes, exactly.
Yeah. Michigan State.
Okay, all right.
Yeah.
Hi, Josh.
Hey, Hollylynne. So great to have a chance to talk with you this way. Thanks for pointing me in the right direction a few weeks ago.
Cool.
That was really helpful.
Yeah, good. Well, Josh is certainly thinking about things in a science context, Bill.
Yes, I know. That's great. So, how did it feel to you?
Yeah, it felt good. I mean, it's very hard to try to plan for interactivity